Welcome to Chemistry 2, Unit 2 Thermochemistry. This is Lesson 4 on Hess's Law. This is video number 3. And in this video, we're going to look at another example of Hess's Law. So now we're given three equations. And we're looking for C graphite plus 2H2 gas yields CH4 gas, which is methane. So again, I'm going to look at my unknown reaction. This is the one that we're striving for when we add all our givens together. C graphite, we need one of them on the reactant side. So I can isolate C graphite in this first reaction. It is on the correct side and the correct number. So I'm going to keep this equation the same. So I'm going to go ahead and write it out. C graphite plus O2 gas yields CO2 gas, and we have negative 393.5 kilojoules. So now if I look, and we are going to change one thing, and we're going to change this water to a gas. I messed up when I was typing this out. So with this next one, if I look, I have 2H2 gas that I need. The only reaction that has H2 gas is our second one, but we need two of them. There's only one in the given. So I'm going to multiply all the coefficients in my delta H by 2. So I'm going to end up with 2H2 gas. 2 times 1/2 gives me 1 oxygen, yields 2H2O gas, and then I have to take 2 times negative 285.8 kilojoules. So the last thing that I have to do is worry about CH4. CH4 is on the product side, and if I isolate it up here, it's in equation 3, but it's on the reactant side. So I have to reverse this reaction. So I'm going to end up with CO2 gas plus 2H2O gas yields CH4 gas plus 2O2 gas. Since I reversed the reaction, I have to reverse the sign, so this becomes positive 890.3 kilojoules. So once I've manipulated everything, I'm going to start crossing things out. So if I look for something that crosses out, I see that I have CO2 gas on both sides, and we have one of each, so it's going to cross out. I have two waters on opposite sides of the arrow, and they're both gases, so they completely cross out. And I have two oxygens on this side, but I have one here and one here, so all the oxygens are going to cross out. And I'm left with C graphite plus 2H2 gas yields CH4 gas. And that matches what I want here. So all I have to do now is add all of these values together, and you should get negative 74.8 kilojoules. That is our answer. Example number 3 is a little bit harder. Once we get into some of these, they can be rather lengthy. But again, if we follow the guidelines, we should be fine. So here is what we're looking for. 2 solid aluminums plus 3 gaseous chlorine atoms gives us 2 aluminum chloride solids. So if we look for aluminum, aluminum is only in one equation up here, and that is number 1. We need 2 aluminums on the reactant side, and wouldn't you know, we have 2 aluminums on the reactant side. So I'm going to keep this equation the same, and then I'm going to rewrite it. 2Al solid plus 6HCl AQ. Remember, AQ stands for aqueous. Yields 2 aqueous aluminum chlorides plus 3 hydrogen gas. So negative 1,049 kilojoules. Next, I have chlorine. So Cl2 gas, and I need 3 of them. So if I look, The only equation that has chlorine in it is this one, number 3. But we only have 1. So I'm going to have to multiply this one by 3. And that gives me 3H2 gas plus 3Cl2 gas yields 6HCl gas. So now I have to multiply 3 times my delta H value. Whatever I do to the equation, I do to the delta H. So we have the aluminum, we have the chlorine, now we have to get aluminum chloride solid. Be careful, because if you look, we have different forms of aluminum chloride in this reaction. We have it in solid, aqueous, and it's also up here as aqueous. So this is the only reaction right here where it is in the solid form. And we need 2 of them on the product side. Here in this equation, we have 1 of them on the reactant side. So we have to multiply this one by 2 and reverse it. So I'm going to end up with 2 aluminum chloride aqueous yields 2 aluminum chloride solid. So I have to multiply this by 2, but I also have to reverse it, the sign, so I have 2 times positive 323 kilojoules. So that takes care of that, but we have a problem. If we look at this, we have 6 HCl aqueous here and 6 gaseous here. Those do not cross off because they are in different states of matter. We haven't used this equation up here, but this equation helps us get rid of these. So we need to get rid of 6 HCl aqueous, so we're going to have to multiply this reaction by 6, so we can have 6 aqueous on this side and 6 gaseous on this side, so they cancel those out. So 6 HCl gas yields 6 HCl AQ. And that means that we'd have to take 6 times negative 74.8 kilojoules. So now if we start looking at what crosses out, nothing crosses out with aluminum. So we have 2Al solid. 6 HCl aqueous cross out on both sides. 2Al Cl3 aqueous, we have on opposite sides of the arrow, so this one crosses out with that. 3H2 gas crosses off with the 3H2 gas here. 3Cl2 gas does not cross off, so plus 3Cl2 gas. 6HCl gas crosses off with this one right here. And the only other thing we have left is 2AlCl3 solid, which is what we want. So we have found our equation, and now we have to add all of these up. Be very careful with your signs. When you do this, you should get negative 6,387 kilojoules as our answer. Very, very exothermic for that reaction.